So the final option with linear transformations is to use your graph transformation knowledge to help you out. And of course, you know that when you write graph transformations that are applying to x values, the way that they're written appears, as I affectionately call it, topsy-turvy to what's actually happening on the graph. So a translation of a unit in the positive x direction would be written as a minus a in the equation. Similarly, a stretch of scale factor 2 parallel to the x-axis would be written as x over 2 in your equation. So we're going to use that knowledge to help us out. So what I'm going to do is I'm going to establish that my w roots, so my roots for w, are 2 lots of my z roots plus 1, which is absolutely correct. That is what we've got. If we had alpha originally, we've now got 2 lots of alpha plus 1. But that now allows me to rearrange for z, and I would get w minus 1 over 2, which does actually represent the transformations as you'd expect to see them in the equation. So I can now take this expression here and substitute it into my original cubic. Z cubed minus 3z squared plus z plus 5 equals 0. So w minus 1 over 2 all cubed minus 3 lots of w minus 1 over 2 squared plus w minus 1 over 2 plus 5 equals 0. Now all we have to do is sort this out. And I'm laughing because you can imagine what happens with the algebra when we try and do this. In fact, this is not the first time I've attempted to record this video because I have made several mistakes on it, just trying to show you what to do and show you how not to make mistakes. So please, I beg of you, when you try these questions, really take some care and some time working your way through the algebra. It's heartbreaking to see the actual mathematics go well, and then your algebraic accuracy cause you to drop loads of marks. So yeah, be really careful, please. Just keep an eye on it. So this is w minus 1 all cubed over 8 minus 3 lots of w minus 1 squared over 4 plus w minus 1 over 2 plus 5. I know that feels like a really silly step, but I tell you what, the denominators, worst thing. This is where people make all the mistakes. You could multiply by 8, I guess, now to get rid of the denominators. That would be nothing on the first one, 6 on the second, 4 on the third, and a 40 on the end. So it's not right, that's a 5 again. There we go. All right, expanding. W cubed minus 3w squared plus w minus 1 minus 6 lots of w squared minus 2w plus 1 plus 4 lots of w minus 1 plus 40 equals 0. I hope this is going okay. I'm sure you will be letting me know across the sound waves if it isn't. 6w squared plus 12w minus 6 plus 4w minus 4 plus 40. And we've got w cubed minus 9w squared. This is looking good. This is looking good. Oh, I've missed a 3. Whoops. So 14, 19, w, yes, minus plus 29. Yes, good. And there we go. So it's actually quite a nice way of doing these sorts of questions. You don't have to go into roots of polynomials. This is a totally acceptable method for finding the new equation here.